Rover is about to reach the red planet. So the question now is, will it make it to the surface? And joining us on the phone this morning is Thoma, I believe, mechanical lead at the Mars Science Laboratory Project. Thank you for joining us this morning, Ben.
Good morning.
So there's a lot, obviously, at stake here. When is the rover expected to make its final descent onto Mars?
So it's tomorrow night, Sunday. On the East Coast, it would be at 1:30 in the morning, or where I am out here at the West Coast, it's actually tomorrow night at 10:30 Pacific time.
So can you talk about some of the challenges in this mission?
Well, the first challenge that we're going to see is actually the landing process. It's the most aggressive, bold, challenging landing system that we've designed for a surface mission on the planet. The entry body of the vehicle comes into the Martian atmosphere at 13,000 miles an hour. And just 7 minutes later, what's referred to as 7 minutes of terror, we have to be gently on the surface of Mars. So that's equivalent to you driving your car on the freeway going 65 miles an hour and coming to a complete and controlled stop in just 2.1 seconds.
Wow. And there's a lot entailed to try to make that happen, right, as far as the landing goes?
There's a whole series of events and sequences that all have to go just right. So when we're coming into the atmosphere, we slam into the atmosphere, and one of the things that we do is we slow down. We use the atmosphere, friction, to slow ourselves down, much like the Space Shuttle does or the Apollo landing capsules do. It gets so hot that the front of the body reaches almost 4,000 degrees Fahrenheit, and we can experience up to 15 Gs, Earth Gs, during that deceleration pulse. Once we slow down, we then have to deploy a supersonic parachute. So we have a parachute that can deploy at 900 miles an hour. Just under Mach 2. Once the parachute's deployed, we can jettison that heat shield. We no longer need that heat shield in front of us to protect the body. At that point, we have a radar that can start to sense the ground beneath us and tell us exactly what our altitude is and exactly how fast we're going. When we slow down to just a couple hundred miles an hour, the rover, with a jetpack above it, drop out from that parachute and light up rocket engines. We're carrying about 1,000 pounds of rocket fuel. We light up our engines and we start to descend until we're basically 60 feet above the surface. At that point, the rover is lowered on a rope, a 20-foot rope, lowered beneath this jetpack. The jetpack continues to fire, and it gently brings the rover on its wheels. So the wheels here that it's going to drive on do double duty as its landing gear. And the jetpack, that descent stage, gently sets the rover down on its wheels going less than 2 miles an hour. At that point, the rover cuts the cables, and the jetpack flies off and crashes.
And obviously, this whole process and mission is to get the rover to land safely on the surface. Worst case scenario here?
Worst case is it's a bad day on Mars, and that doesn't come without its challenges. In the history of Mars missions, including those from Japan and Russia, 2/3 of all Mars missions have failed. Now, the U.S. has done better. We've had several successes in the last few years, but it's by no means a given that this is going to be a successful landing. So we're all waiting with anticipation. But we're confident it's going to work. But it certainly has its challenges. Okay,
real quickly, just 20 seconds left. Can you tell us what will the Mars rover be doing once it does land on Mars?
Sure. So this is a chemist, unlike the last rovers that are up there that are geologists. This one's really going to be looking for the building blocks of life. Could life have been sustained on Mars? Looking for the signs of organic compounds, amino acids. Was it habitable in the past for life on Mars?
Ben, Thoma, thank you so much for joining us. Always fascinating stuff. We appreciate it.
My pleasure.